Hello there. In today's topic, let's discuss imaginary numbers. Let me ask you a few questions. How many apples do you see? You owe me rupees 10. What does it mean? Divide the pizza between 3 people. How much each gets? While answering the above questions, we don't say or think like, thanks to natural numbers for helping me to count the apples. I hate negative numbers for helping you to remember my debt. I'm grateful to rational numbers for helping me to share a pizza with my friends. Buying apples, owing money, sharing pizza are common things in everyday life. Numbers are assimilated into our lives like air and water. Now take your calculator and find square root of minus 1. What do you see? It will throw you the error, not a number or invalid input. Surprised? If it's not a number, then what it is? This type of number is called an imaginary number with a property I square equal to minus 1. In this post, I'm going to discuss how to visualize imaginary numbers and nothing more than that. Let's draw a number line and plot the answers for the 3 questions that I asked earlier. For the number of apples, the answer is 4, which is a natural number. For the debt that you owe me, the answer is minus 10, which is a negative integer. For sharing pizza, the answer is 1 by 3, which is a rational number. If you observe, you can see that we moved right or left on the number line to plot our answer. The number system has been expanded over centuries and included different types of numbers like natural numbers, zero, negative numbers, rational and irrational numbers. Every real number has its own place on the number line. But where can we place square root of minus 1 on the number line? At first, what is square root of minus 1? Is it 1? No, because 1 into 1 is 1. Is it minus 1? No, because minus 1 into minus 1 is also 1. Positive numbers won't work here. Negative numbers also won't work here. So what number that multiply by itself gives a negative number? Before addressing this, let's see what happens if you multiply by minus 1 repeatedly. That is, when you multiply minus 1 by minus 1, you get 1. When you multiply it again by minus 1, the answer is minus 1. When you multiply again by minus 1, the answer is 1. So what do you observe? It creates a pattern like 1 minus 1, 1 minus 1, 1 minus 1, and so on. So it rotates 180 degrees and flipped back and forth between 1 and minus 1. Till now, you have seen numbers as one-dimensional on the number line. What if numbers are two-dimensional? What if we rotate it by 90 degrees instead of 180 degrees? Let's see. Draw an imaginary axis right on top of the real axis in a perpendicular direction and see what happens if we rotate from 1 to minus 1 by 90 degrees. Let's call this number I when rotated by 90 degree. As you see in the above image, when you rotate 1 by 90 degree counterclockwise, it enters the imaginary dimension I. That is, 1 into I is equals I. When you rotated it again by 90 degree counterclockwise, it turns into minus 1. That is, I into I equal to I square equal to minus 1. Sounds familiar? Is it not the same as x square equal to minus 1? Let's see what happens if we do the same in clockwise direction. Now rotate 1 by 90 degree clockwise. It enters the imaginary dimension minus I. That is 1 into minus I equal to minus I. Rotated it again by 90 degree clockwise. It turns into minus 1 again. That is minus I into minus I equal to I square equal to minus 1. Rotating twice by 90 degree, 1 turns into minus 1. Thus we found the solution for x square equal to minus 1, which is nothing but plus or minus I. Thus, imaginary numbers are the natural extension of a number system from one dimension to 2 dimensions. The term imaginary number was originally coined in 17th century by Descartes as a derogatory term. Early mathematicians believed that square root of minus 1 is meaningless as it didn't correspond to anything people could think of in the real world. A complex number is a number that can be expressed in the form a plus bi, where a and b are real numbers. A is the real part and b is the imaginary part. Alternating current using in our home, shock absorbers on vehicles, and almost anything that involves waves uses this type of number. Don't be overwhelmed with these phrases. Complex numbers, though the term contains complex, is used to make calculations easier. Thanks for watching my video. Please subscribe to my channel and visit my website www.mathyon.com.